Hi, I'm Tim Standing. I'm from Otherworld Computing. I run the Macintosh software division, or a group at Otherworld Computing. We do SoftRaid, we do Dock Ejector, we have a ingest product for ingesting from camera cards that does checksumming and verification. And today I'm going to talk about, if I can find my clicker, I'm going to talk about why we're still losing volumes. The reason this talk came about was because I was walking around San Francisco. We see a lot of these self-driving taxis. I had to stand on the corner for maybe 3 minutes before this one came by. And I thought, you know, we have this incredible technology. We've got AI coming. You get on an airplane now, and you never think, oh my God, I'm going to crash, right? It's like completely reliable. So we have these technologies that are completely reliable. Why is it that our storage for our computers is not of that caliber, right? If everyone knows people have lost volumes, people have lost files, had corrupted data, what's causing us to be in this position where we don't have that level of confidence in our storage? And that's what I'm going to dig into in this talk. Hopefully at the end you'll have a list of recommendations that will greatly reduce the chances that you're going to lose a volume or lose data from a volume. So I was a volunteer firefighter for 4 years. This experience, what I saw people go through, what I saw their houses go through, what I saw them go through medically, pretty dramatically changed my attitude towards life, and more specifically for this audience, my attitude towards backup. So a lot of times I'd go and see a fire. At the end of the fire, there would be the computer, and it would look like a tin can that had been in a campfire. So what I have gradually gone towards is the backup strategy that Netflix requires for all their productions. And this is what they call 3-2-1 backup. So you have your working copy of your data, and you have 3 other copies. One of those copies, so you have 3 separate copies. 2 of them have to be on different media, a server, an LTO, a Linux box, and a Mac. You know, just different media, so you have different susceptibilities. One of them has to be off-site. I run this in the office. We have, you know, source code backup to Git, to our Bitbucket, and then we have source code backup to a server, and source code backup to local drives, and source code backup to off-site drives. If the building burns down, I can still build all our products. All I do is go to the Apple store and buy a new laptop, and I can be up and running in probably 2 hours. That's the type of thing, that's the type of backup strategy that I encourage everyone to use. So many businesses go out of, you know, close their doors because they have a fire or ransomware or something else that takes them out, and you should not be in this category. For me, the offsite backups, I have 2 of them, and I rotate the oldest one in every time I do a backup so I can roll back if the backup got corrupted. So I want to start talking about things that cause people to lose volumes. And one of the things that has been out on the web for a long time is this concept of bit rot that came out of the study by CERN, where they looked at volumes, looked at data on disk drives, and especially in the Linux world, there came this idea that data sitting on a disk drive is susceptible to corruption. It's the reason ZFS checksums all the data, not only the metadata, but the data itself on the volume. And I thought, it just doesn't make sense what they're saying. My original background was in biochemistry, so I'm heavily experiment-based, and I look for, someone tells me something, I want to go prove it to myself. So what this paper looked at, they did 2 tests, but they basically both came up with the same results, so I'm just going to go over one. They had 3,000 servers. Each server, every 2 hours, would write out a 2 gigabyte file and read it back. And it was a pattern. It was a random pattern, so they could read it back and verify it. And they did this, and they came up over 5 weeks with 500 errors. Okay, this is one every 5 terabytes. So that seems like, you know, we have 20 terabyte volumes. That means if you read the whole volume, you get, you know, 4 errors. That doesn't sound right to me. So they did a separate experiment, and they came up with the same error rate based on regenerating parity data on RAID 5 volumes, they got about 1 in 5 terabytes an error rate. So I set up several years ago to try and reproduce this. I had 2 RAID 5 volumes, both with 15 disks. The first one just wrote out a pattern, read it back over and over and over again. And the second one just wrote the pattern out at the beginning and then went and verified it every 10 days. So the second one's looking for like the passive data corruption that bitrot is supposed to be describing. And the first one is like, is there a problem with actually reading and writing data? I ran this for 18 months, okay? It wasn't just like a thing, it was like in the back of the room running all the time. The only time I saw data corruption was when the power dumped in Mill Valley and everything went offline. The machine that was writing out a file, when I went back and verified it, the file was wrong. It's no surprise there, right? So I did 22 petabytes of data and didn't find a single instance of bit rot. Fast forward to this past year, I'm working on RAID 6 and RAID 6 Plus. I want to make sure that it's 100% reliable. Unlike testing RAID 5, where you can pull any drive and recreate the data and the math is always the same. With RAID 6, when you pull 2 drives, the math is very different depending on which 2 drives you pull, and I didn't want to have our tester have to sit there and manually pull drives, especially as you get up to 16 disks per volume. So I wrote a Python interpreter and a scripting language that allows me to test all the possible permutations. And we now run this with every build of the software driver. It takes about 8 days to run. On HDDs, it goes through about 600 terabytes of data, and on NVMe blades, it goes through about 1.9 terabytes. That is equal to roughly 5% of the life of the blade. So my boss gets pissed at me if I run it too many times, but I keep telling him it's our product, it's got to be 100% reliable. Our RAID 6 code at the moment is to the point where if it was up to me, we'd be shipping it in 2 months, but we're shipping our driver now as part of macOS. It comes pre-installed with macOS, so it will ship in the spring of 2026. If you want access to the beta copy of it, it'll probably be out in 2 months, and you should reach out to me. We're at the point now where it takes us 36 to 48 hours of this type of really intensive testing before we see a problem. So I'm bound and determined to fix that last bug. Just as so you have some background about the types of products that we do. At OWC, we do Thunderbolt docks, we do 10G Ethernet adapters, we do camera cards for Red cameras and Sony and Ari and everybody. We do ingest readers. We have single and multi-drive local attached storage. We have NAS for film and video. And I'm really going to focus on the single and multi-drive enclosures because that's where I spend all my time. This is our Electron. This is a single drive enclosure. We're going to raffle off 4 of these for attendees. Aid is going to do a raffle and announce winners, I think, later today. It's, if Apple was going to do an external drive, this is what they would do. It's milled from a solid piece of aluminum, just like your Mac Mini and Mac Studio. It's waterproof to IP67. It's will read and write at 1 gigabyte a second, and it comes in sizes up to 4 terabytes. And just to give you an idea of how reliable it is, we ran over with a car. We actually had to do 6 takes of this before I got the thing to bounce the way I wanted. It's also waterproof to IP67, which means 30 minutes at 1 meter. You know, you don't have to worry about it. If it's in your camera bag and you like take a dump in a kayak, it's still going to work. We also have 2 different 8-drive enclosures. This is one of them. It takes 8 SATA drives or 4 SATA and 4 U.2 drives. It's just electrically, it's a JBOD. There's no RAID hardware in it, and it runs with soft RAID. Everyone says, oh, well, software RAID is really slow. I think you can see from these numbers it's not really slow. Then people say it uses a ton of CPU bandwidth. And in actual fact, we're using 2.2% of the total CPU bandwidth on a machine writing to this volume with RAID 5. The next product I want to talk about is the Excelsior 8M2. This is a 16-lane PCI Gen 4 card. It has 8 blades in it. It was the product that Apple put on their web page for the 2023 Mac Pro when they introduced it, when they said up to 26 gigabytes a second. Well, I can't quite get 26 gigabytes a second out of it, but I can certainly get 22 all day long. So this is screaming fast, right? But what's even more incredible is that you can do RAID 5 on it and get just under 10 gigabytes a second writing and just under 20 gigabytes a second reading and still be protected from a blade failure. Lastly, again, the question gets to be how much CPU are we using? We're using under 10%. It turns out 3% of this is actually APFS, and 6% of it is our RAID calculation. Lastly, we just introduced this last month, the Thunderbolt 5 product. It's a Thunderblade X12. It actually has 12 blades in it. It's the size of 2 paperback books. It's tiny. No fan, and it just plugs in and works, and it's designed for the film and video industry. Currently, we're shipping in sizes up to 48 terabytes. In 2 months, we'll be shipping a 96 terabyte version. So if you need the screaming speed on your Mac Studio, this is your answer. Here's the speed we're getting. We've pretty much maxed out Thunderbolt 5 for storage with RAID 0, and we're not far behind with RAID 5. Okay, so RAID 6, everyone says RAID 6 is slow. This is the benchmarks we're getting currently with RAID 6, with the driver version that I just pushed to test last week. So as you can see, we're over 85% of the read and write performance of RAID 5 with our RAID 6 implementation. And this sort of makes sense if you think about it. Say you have 8 drives. With RAID 5, 7 of those drives are for data and 1's for parity. With RAID 6, 6 of the drives are for data and 1 is for parity. So you end up throwing away more of the data in RAID 6 and less of a smaller percentage of it is used for your volume. So it makes sense that it's going to be a little slower. But I think this sort of puts the nail in the coffin of RAID 6 being slow, especially when we're looking at 17 gigabytes a second for reading and 8 for writing. So I want to switch gears a little bit and start talking about drive failure. Drives fail, and it's the #1 thing that people think of when they think of why is it that I lost my volume. Backblaze every quarter for, I don't know, a decade at least, has been listing the drives that they're using by model and the annualized failure rate, the AFR. So you can say, okay, I want to go buy a 12 terabyte drive. You go to their list, you say, oh, well, they're not having very good luck with this brand, but they're having great luck with that brand. Okay, I'll go see if I can find one of those, that drive, that model, that size. I think it's great, and I've been looking at this, and I thought a while back, well, we should be able to predict what sort of failure rates we have for different size volumes just by taking their numbers and doing the math. And this is what I came up with. This is for a drive that has a 1% annualized failure rate, you're going to see an 8% chance of one of those drives failing in a year and an over 25% chance of it failing in 4 years. 1% is considered really good for a disk drive as a failure rate. 3 is sort of average, and over 4 years, you're going to have more than a 50% chance that one of those drives is failing. So a lot of people are still using RAID 0 for scratch drives and everything. I think RAID 5 has gotten fast enough that people should be using RAID 5. I'm sure I'm not telling you guys anything because you're probably all using RAID 5, right? But you'd be surprised how many people are using RAID 0, and it makes me nervous. They say, oh, it's a scratch drive, and I say to them, if it just disappeared, where would you be? What would happen? So when I started looking at disk drive failure, I thought it would be really great if there was a way to predict when a drive was going to fail. And it turns out back in 2007, Google did this great study. They had 2 engineers. At the time, they had 10,000 HDDs in these server nodes, 2 drive per node. And they use smart data. Now, SMART is this sort of self-testing thing that's built into SATA drives. It's also built now into NVMe. And it's the ability for the user to say, go test yourself. And the drive does some tests, and it says, yeah, I'm good. No, I'm not good. As with all the self-testing, self-reporting things from manufacturers, it's not terribly useful. But what is useful is it also includes the set of parameters that the drive has that it reports back. This is how many hours they've been on. This is how many times it's spun up. This is how many times they've been powered on. This is how many times they've reallocated a sector. This is how many times this is my temperature, all these things. So what the engineers did was they set up a remote job for all of their server nodes, and the remote job ran every 24 hours, scooped up all the smart data and the smart test results, sent it off to a database, and then whenever a server node disappeared, they'd email the guy who is responsible at that part, wherever it is in the world, say, you pull that server node. The server nodes are a motherboard, 2 drives, and a lead-acid battery. Said, okay, did you pull that node because of a problem with the motherboard or because the drive failed? And anytime it was the drive failed, they went back through their database and said, what events happened? Is there any correlation between an event happening with smart data, with the smart attributes, and the drive failing? And what they found was they had 2 correlations, or sorry, 3. The number of reallocated sectors, the number of probationary sectors, which are sectors that the drive, you remember the drive's reading an analog magnetism on the platter. It's not quite strong enough, but it's not so low that it's going to not read correctly. So that's probationary sector. And the last is an end-to-end error. It created some error during the read it was not able to recover from. If any one of these counters went from 0 to 1, they would say, okay, this drive is 20 to 60 times more likely to fail in the next 2 months. So I took this data and I incorporated it into SoftRaid. And since 2010, we've notified people that their drives are about to fail. We also do the smart test, but it sort of doesn't seem to be all that useful. What this allows people to do is they get a notification the drive's likely to fail. They can still use it, but they can wait until the weekend and do their rebuild for their RAID 5 volume over the weekend when no one's using it, rather than be in a crisis when the drive fails absolutely and they're actually in the middle of a crunch and they are trying to do a rebuild while they're using the volume. So we do anonymous data collection from users, and I wanted to go and find out how many people were actually getting disk drive fail predictions using the smart data and how many people were failing smart tests. And you can see smart test failure, almost nobody gets it. I think we have 1 drive in our lab that actually fails smart, and we probably have 10 or 15 that are predicted to fail, some of which have only 3 or 4 reallocated sectors, some of which have 20 or 30,000 reallocated sectors. And what we find is drives start failing, and then they pretty rapidly start accumulating more sectors. We have customers who report that we don't believe you, we're just going to keep using the drive, and they usually come back to us 2 to 4 months later and say, guess what, the drive actually failed. By our estimate, 3/4 of the drives that fail are predicted to fail before they fail. So 1/4 just fail without any warning, but 3/4 give you warning if you're looking for it. With NVMe, obviously you can't use reallocated sectors as an indicator because they're constantly reallocating sectors as cells wear out. But you can use the uncorrectable error count, and you can use the media life remaining as predictors, and we use both of those. There are also 3 critical alerts that NVMe has built into Smart. One is for high temperature, one is for media that doesn't store data correctly, either DRAM or flash, and the third one is a hardware error. These sound like they would be great, right? But the problem is all 3 of them latch the drive into a read-only state. And that's, your drive is basically toast at that point because macOS won't mount a volume that is open if it's on read-only media, and your drive has failed at that point, so it's not a good predictor. So we don't use those we tell you when you get them, but we don't use them as a way of predicting when your drive is going to fail. NVMe drives tend to fail much less frequently than HDDs, an order of magnitude less. So, but we are seeing people getting uncorrectable errors, and they are indicators. Sometimes people don't believe that there's a problem, and you say, hey, guess what? You've got 100,000 uncorrectable errors on this drive. You should get rid of it. I've been working with Mark James here on the right for the last 20 years. What's unusual about our working relationship is we work in the same office. He's our lead tech support guy. He answers the emails that for anyone who has a problem. And what's really unique is we meet every day. So every day I go into the office at 10:30, he comes whizzing in his hydrogen-powered car, sits down, and he tells me all the problems that customers are having. So I've heard, for the last 20 years, I've heard about every single corrupted or lost volume or every single critical error we've had. And it's really helped me focus on making sure that we're addressing our problems and also pushing Apple to fix their problems. We've done a lot of really deep dives on problems that customers have had in the past. And so what I'm going to do for the next 10 minutes is I'm going to run through a little bit of a history of what types of problems we've seen and the frequency that we've seen them in, so you can get an idea of what rate people are seeing problems and how they might affect you. So the first thing is back in 2008, we didn't have RAID 5, we only have RAID 0. As you can see, 1 out of 100 people were losing volumes due to disk drive failure. This was my motivation to get RAID 5 written, aside from the fact that everyone was asking for it. But what's more important for us currently is that 1 in 3,000 people were losing volumes due to user error. They clicked on the wrong disk, they initialized the wrong disk, poof, the volume was gone. They certified the disk, they zeroed it out, whatever it is, but they did something catastrophic. So what I did in 2010 was I added this feature called Volume Safeguard, which locks, when you create a volume, it's safeguarded, and it prevents the software application from initializing or zeroing or doing anything destructive to any disk in that volume. So you're protected, right? If you're using disk utility, you don't have this. So my guess talking to people this week and having heard about several people who have accidentally erased volumes, I know I have done it twice in my life, accidentally erased the wrong volume. I think this is a pretty good rate for how often this is occurring among users. So when I added safeguard, the volume loss to user error went down to 1 in 2 million, less than. So it would be great if I could get Apple to incorporate this in disk utility. It's not going to happen. Again, we have volumes still failing due to disk loss because we're at RAID 0. When I added RAID 5, of course, the volumes lost due to disk failure goes way down. This is where we are in 2014, and we're going to zoom in. So our scale goes way up. So we see that we've got the volumes lost due to user error. We have volumes lost due to all the disks disappearing at once. This was caused by, it's caused by several things, but it was caused by an error in macOS. There was also a bug where drives would change position when the Mac came out of sleep. I have a hypothesis as to what was going on, but literally you can have 4, say, SATA drives, and you come out of sleep, and the BSD disk number that point to this physical drive would swap positions with another physical drive, and your writes for a volume on one drive would actually go to the other volume, even though in memory the kernel thought that this first drive was still intact. So with RAID, obviously, you're going to start writing to the wrong location on the wrong disk for blocks. But if you have 2 like non-RAID volumes and they swap position, you're going to start writing like allocation block tables and metadata to the wrong disk. And you can imagine what happens. It takes like a minute or 2, and then all hell breaks loose. So what I did, because I couldn't get Apple to fix it, was I put code in software where I kept track of the actual disk number, like the UUID for a disk that's part of the software metadata. I kept track of it vis-a-vis the BSD disk number, and then when you came out of sleep, I reread that data, and if it didn't match anymore, I just write protected the volume and put up a dialog saying restart. Apple actually ended up fixing this in later, let's see, in 2018 they fixed it. So that was no longer an issue. But you'll notice that there's a couple things that have been here all along. One is volumes lost due to a system software update, right? Are volumes lost to all disappearing? It's still there. It's much less than it used to be, but it's still there. So we're going to dig in pretty heavily on that one in a few minutes. The disk changing position is gone. It got fixed in macOS 13, thank God. We have a much better relationship with Apple since we started shipping the driver as part of macOS. We now meet with them once a week. We feed them bugs. They usually get them fixed pretty easily, or pretty quickly, I should say. So the other thing you'll notice is from 2017, if you look at the top number, we went from 1 in 2 million people losing RAID 5 volume due to some problem to 1 in 40,000. What's going on? What happened in that 5 years that caused this huge increase in people losing data? Well, I dug into it and found that it only happened, people were losing volumes when a drive got replaced or failed, and it only happened on NVMe. And so the beginning of last summer, I just said to my boss, I'm going to fix this bug. And I spent 8 weeks on it. And at week 7, my tester in Taipei discovered that it only happened if you had trim enabled. Trim being the facility that allows you to take, allows the file system to tell an NVMe or SSD blade what part of the disk corresponds to a volume that just got deleted. So SSDs use flash media. Flash media is a write once in that you have to erase blocks before you write to them. So once you've erased a block, you can write to it, you can write to the next part of it, but if you want to go and rewrite it, you have to read all the data, erase it, and then write it again. So when the way that they speed things up is by a RAM cache and also by having a huge stash of pre-erased blocks. But you can speed this whole thing up if the file system tells the drive, hey, I no longer need this whole section. You can put it on your list, and at your leisure, go and erase it. So that's what it is. It goes and erases it in the background, makes everything fast. It turned out that I had made a mistake in the very edges, my calculation on the very edges of an area that was being trimmed, and I was off by a little bit, only for the parity data. So everything worked fine until you lost a blade and needed the parity data to recreate volume data, and then there was, there would be some data corruption. So the reason it was hard to fix also was it was one of those things where you could copy files all day long and everything worked fine. It turned out I had to write a 1 to 200 gigabyte file and then read it back. And then there's a certain set of steps I would do. I'd reinitialize the disk and then go read it from the degraded volume. And about 5% of the time I could see the error. So it was one of those things that took hours to reproduce. And when you're looking for, it would be 16 corrupted bytes in 200 gigabytes. It's hard to find those types of bugs, and I'm really grateful that my tester in Taipei, he persevered so much, and he found the one telltale thing that had to do with trim. And as soon as he found that, I found the bug in like 2 days, and we had a fix done by the end of the week. So that was really excellent. So let's keep going with our volume failure rate. You'll notice that we still have volumes disappearing or getting corrupted due to disk disappearing. This is actually, I'm using the same bar or the same description, but it's a slightly different bug. It comes from this. I don't know if you've ever seen this. I see someone nodding. Yes, great. So I'm going to tell you what's going on here. And it's actually goes under that category of why don't we have reliable data? It's a really simple problem. How come it's not solved? It turns out to be due to hibernation. So if you're old like me, you remember the days when a laptop, if you left it with your half-finished, masterpiece, whatever it is, or your code, and you closed the lid, and you then got called away, and you were away for a day or two, and you came back, the battery had drained, all the contents of RAM had been erased, and you lost all your work. So both macOS and Windows came up with this great idea called Hibernate, where they take an image of of the RAM and write it out to some file, and then they shut down the computer and turn off RAM and turn off everything so you're not draining the battery. When you start it back up, the boot process involves putting all the RAM, filling the RAM with the image and then resetting the processor to the exact state it was when you stopped. So it's cool, it's really wonderful, it works, except there are 3 critical steps here. 1, you've got to write out the entire contents of RAM. 2, really importantly, you've got to flush the volume cache and close the volume and unmount it. Right? Otherwise, you've got the equivalent of just yanking the cable, and all that stuff that's in the volume cache is toast. So, and then you turn off the power. The unfortunate thing is, this is one of those situations where one team thinks they're doing a great job and another team thinks they're doing a great job inside Apple, and they're not really talking to each other or thinking about what the other team needs. And so what we find is that the SATA driver people said, oh, we're going down, yes, let's tear apart the SATA drives and get rid of the disks that they represent, and we'll be good, right? So, but they didn't realize that the volume's still open and they still have clients that are using them to write to the physical media. So the volume then, if you look at the trace log through the driver as this process happens, all of a sudden the drives disappear, you've got a volume there, and I was seeing between 1 and 300 write operations going to a non-existent, coming through the software driver, and then all of them failing, right? But you don't get any error notification because guess what? You're in the shutdown process. You're about to power off. All the user notification, all the logging, everything is like not working anymore because it's been turned off. So you get to the point where you turn off the power, all this information that's in RAM, poof, gone. And if it's something, HFS is not, in spite of the fact that it's got a journal that's supposed to solve everything, it's not great at surviving a cable pull on a live volume. You can do this, you can try this yourself. Set up an HFS volume, start writing a big folder of files to it, and yank the cable. And in my experience, you can do that test maybe 4 or 5, up to 10 times, but certainly by the 10th time when you plug it back in, it won't mount. It's toast. So you're basically doing this exact thing when your machine goes to hibernate. APFS is much smarter about handling these things. If you do that cable pull test, I can do it 20, 30, 40 times, and the volume still mounts. You'll lose data, but the volume's not corrupted. Okay? So this is one of those how far we've come with with APFS, but it also hides the root of this problem, which is that we're not actually handling these things correctly, or the file system isn't. And this is documented. I've sent it to Apple. They're working on it. There will be a fix at some point. In my final step, I want to go through sort of a list of what I consider the key things you can do to make sure your volumes are more reliable. The simplest one, the biggest win, is to have a dedicated machine that you erase disks and volumes on. So it'll keep you from erasing the wrong disk. It's simple. I use an old Intel laptop. It sits on the corner of my desk, and anytime I want to erase something and plug it in, do it there. Test all your storage before you use it. So when I get a new storage and I'm going to put it in place for a server, I do 2 things. I run AJ system tests on it continuously for 24 hours. And then I have a script that just basically generates a random data file, copies it onto the volume, and fills the volume with a random data file, and then goes back and verifies it. And I'll run that script over a weekend, maybe longer. It takes me a couple days to test it, but if you're going to put something in production, test it first. Don't just pull it out and plug it in and go, hey, it's good. You might have one of the few disk drives from that batch that is crappy, or you might have bad RAM if it's a server, whatever. Just test the living daylights out of it before you put it in production. If you're like me, when you set something up, you expect it to last for 4 or 5 years before you have to touch it again. Disconnect all your external storage before you do a macOS update. I was hoping to have discovered root cause of what's going on with this, but each iteration of the test is pretty involved because you have to roll back an install to a previous version of macOS, then run through the install process, then figure out what's going on and do the tracing. And I didn't have time to do that before I left, but it's on my list for the next month, is to write up this bug and submit it to Apple. Use smart monitoring. It's there. It works. It works for NVMe. It works for SATA. It doesn't yet work for USB 3. It works for USB 3 on Windows, but not on macOS. I have a feature request into Apple to add it to macOS. I believe it's going to be added sometime, hopefully this year. But it will give you visibility on when your drives are going to fail, especially for HDDs. It also works for NVMe. Certainly, if you've got a NVMe-based array, I would be using it. You don't have to use SoftRaid, although you can. SoftRaid actually will do the smart monitoring even if you get the free version. So you can download it, use it for 30 days, and it starts nagging you to get a serial number. You can get what we call our standard license serial number, which is free, and then just use the monitoring part of it. Ignore the rest of it. Don't flex your NVMe blades. They look like memory cards. You should be able to throw them in the drawer. Treat them really gently, because there's those flash memory chips have like 90 or 100 layers of flash memory cells. That's how they get their density up. And you can imagine it's like a layer cake with all those layers in it, and a little bit of flexing is going to cause all hell to break loose, especially when the feature size is so small. So unfortunately, the data corruption we see with NVMe doesn't get flagged as an error. It just comes back as wrong data. So if you have a solution where you're pulling NVMe blades out and putting them in and changing them, go and test it when you're done. Just make absolutely sure that you don't have data corruption in there. Disable Hibernate if you've got external storage, especially if you're seeing that error message. And as with malware, also with storage, use the latest version. Apple, we see the changelog for every version of macOS, and there's this feature is like working, or Apple Intelligence is working on this, or all these other things. But it may help some people, but the root thing that people want is a reliable piece of hardware. And there are lots of bug fixes that are going in the kernel for storage that roll out with every version of macOS, and they're not in that list. I did a talk last fall where I went through like the 16 or 20 most common kernel panics in macOS 14 and how many of them had been fixed in macOS 15. It was staggering, and none of them are in that changelog. Lastly, if you want to get OWC products, there's a contact information here for OWC UK. We ship out of Belgium. We do warranty replacement and warranty repair in Belgium, so you're not shipping it across to the US. We have all our products there. We're used to dealing with VAT. We're used to dealing with import. The people there speak at least 4 or 5 languages, unlike us provincial people in the US who only speak American. So anyway, that's it. I'm open for Q&A if you have any questions or comments. If there's something you think, oh my God, I wish storage did this, please let me know. If there's some frustration you have, please let me know. If there's a bug that I don't know about, please let me know. I'm all ears. Thank you. I can't believe no questions. Okay, there's a free beer for the first question.
Hello. You were talking about the specific hardware events that cause disks to fail, but you kind of glossed over the technical detail of what specifically is happening at the hardware level when those events occur that cause the disk to fail. I was wondering if you just want to go into any more detail about that.
Are you talking about events that predict disk failure?
Yeah, the sort of underlying hardware events that were predictors of failure in the Google data.
It's sort of like saying when I drive my car and it makes a really loud grinding noise, I should stop driving it. It's sort of that level of detail. I don't know what's going on. It could be a bad read amplifier. It could be one of the heads is slightly wonky. Who knows what it is? but it's one of these, it's like life insurance, right? If you're going to insure a bunch of people and half of them are heavy smokers and half of them aren't, you know that the ones who are heavy smokers are going to die first, right? So it's the same sort of thing. The Google engineers just looked at what they could measure, which was all these different smart attributes, and they saw which ones correlated with drive death. So I wish I learned more about hard drives in the last year than I ever wanted to know. They now have tables that tell them how much to tweak the head position one way or another so they don't get interference with the neighboring tracks. I mean, it's crazy what those guys are doing. And the new hammer drives that use a laser to heat up the media before they start writing to it for the 30 terabyte Seagate drives, it's crazy. It's just nuts. Anyone else? Okay, thank you very much. And I'm going to be around for today and tomorrow. I have to leave a little bit later this afternoon, but come and grab me. I really want to hear from anyone. You guys are the source of so many great features for our products, and the source of inspiration for so many great investigations we do that end up being new features or bug fixes for Apple products. So thank you.